It's Cambridge O-level paper, and here we have paper 2 variant 1 from May-June 2023. The first question here is, we have a list of oxides and we have to pick the oxide according to the given statement. The first statement here is a solid made during the thermal decomposition of limestone in the blast furnace. When we decompose limestone in the blast furnace, limestone is calcium carbonate. So calcium carbonate decomposes, it gives you calcium oxide and carbon dioxide. So calcium oxide is the answer here. React with both acid and alkalis. The thing which can react with both acid and alkali, they are considered as amphoteric. The only one thing amphoteric here is aluminum oxide. So the first option is correct here. Al2O3 has a giant covalent structure. There is only one here who has giant covalent structure. It's silica. It's SiO2. Then has an ion with an oxidation number of +2. Let's see it. Aluminium, then carbon, no. Then carbon dioxide, no. Yes, calcium oxide. Then it's iron, no. Hydrogen, no. Sodium, no. Sulfur, no. Silicon, no. So the only one which has +2 oxidation state is calcium, which belongs to 2A group. So calcium oxide is the answer. Turn white anhydrous copper sulfate blue. The thing which can turn anhydrous to hydrous is water, because copper sulfate, hydrated copper sulfate, has a blue color, so it converted into with the help of water. Is made during the fermentation of aqueous glucose. Glucose is C6H12O6. When it fermented it gives you methanol and it gives you carbon dioxide. So carbon dioxide is the answer here. The next is group 1 indicate the element lithium, sodium, and potassium. You have to state two physical properties of lithium. As we know that lithium is at the top of the group, so it is soft, it has low density for sure, and it floats on water because of its low density. It has low melting point, it has good thermal conductivity, good electrical conductivity. As it is in the group of metal, it is lustrous, it is ductile, it's malleable. So any of the two properties you need to mention here from them. Potassium react with cold water, and the ionic equation is potassium plus water. It gives you potassium ion, hydroxide ion, and hydrogen. State in terms of electron why potassium is a reducing agent in this reaction. Potassium is a reducing agent because it oxidized itself. It lose electrons. So that is why it is, you know, reducing agent. Then the second question, state the oxidation number of hydrogen. Hydrogen is its molecular state. It has the oxidation state 0. Describe what is observed during this reaction. So it is that potassium floats on water, it moves across the surface of water, it melts, and we have the gas releasing here, so the bubbles, effervescence will be released, and it is colorless solution will be formed, and the smaller pieces will be formed here in the solution, and it gives you a lilac flame at the end. And a sample of sodium chloride is tested using a flame test. When we flame test performed with the sodium chloride, it gives you yellow orange flame because the electrons, they move to the higher shells and get back to their previous shells, and they release that rays, that colors. Then question number 3, the question is about the preparation of salt. Zinc chloride is your salt, and what we have here, zinc chloride is a soluble salt. It is prepared by the reaction of an insoluble base with a dilute acid. That equation is given to you, zinc oxide, hydrochloric acid, and it gives you zinc chloride and water. We have a question example of 3 grams of zinc oxide is added to 50 centimeter cube of 1 mole per decimeter cube of hydrochloric acid. We have to show the calculations that zinc oxide is in excess, and here we have the calculations. So let me just, yes, calculate the number of moles of hydrochloric acid first, which is used here. So concentration, moles divided by volume. And if you want to determine volume here, you have to multiply concentration with volume. And here we multiply the values and we will get the number of moles for hydrochloric acid. And then we calculate the number of moles of zinc oxide. Again, moles, mass divided by molar mass. We put the values, we will get the moles. Now when you determine the limiting reagent, the mole ratio of zinc oxide to HCl is 1 to 2. So therefore, 0.06 mole of hydrochloric acid would react with 0.03 mole of zinc oxide. Since we have 0.0430 mole of zinc oxide, so it is in excess. Right, get back to the questions here. Yes, So the second question here, state why it is important to use an excess of zinc oxide in this preparation. So it why we used it, because we want to end up by using all the acid in the end. That is why we used it is in excess. Suggest how the excess zinc oxide is removed from the reaction mixture by leaving aqueous zinc chloride solution. We do the filtration process and obviously it will be removed. Then the next is barium sulfate is an insoluble salt. It is prepared using a preparation reaction. Name two aqueous solutions that react together to give a barium sulfate. If you want to produce barium sulfate, what we use? Barium nitrate or barium chloride, whatever you want to use, you have to react it with any soluble sulfate. So it will give you the result, right? So barium nitrate or barium sulfate, and any of the soluble sulfate you can pick here. Sodium nitrate is a soluble salt. It is prepared by the reaction of an acid and alkali. You have to name the acid and alkali. You can pick nitric acid as an acid and sodium hydroxide as an alkali. It reacts and it gives you the product. Name the experimental technique used to make the neutral aqueous sodium nitrate. Definitely it is the titration reaction. So you can with the titration reaction you can make sodium nitrate neutralized. Next question here is the question is about compounds that contain phosphorus, and we have phosphide, and the formula is written here. And you have to calculate the number of determine the number of electron, neutron, and proton. Proton is obviously 15. The atomic number is 15. And neutron you have to 31 minus 15. That will be 16. Answer will be given. And electron is 15, and we have three extra electrons, so 16, 17, and 18. 18 electrons are here. State why the formula of phosphide ion is P3 minus rather than P2 minus and P4 minus, because when you have P3 minus, it has its complete outermost shell. That's why this one is the formula. The formula of calcium Ca plus 2, and you have to deduce the formula of calcium phosphide. So P3 minus and Ca2 plus, and you just do the cross multiplication here. So we have Ca3P2. Then calcium phosphate is not ionic compound. Explain why calcium phosphate is an ionic compound, and you have to reason it that why it has a very high melting point. So here we have because it has a very giant structure. Ionic compounds are very strong compound. They have electrostatic force of attraction between them, so their positive and negative ions are attracted, and so they have very strong bonding. That's why. Calculate the percentage by mass of phosphorus in calcium phosphate, and you have to give your answer into significant figures. Again, we have calculations here. So there we have the determinant. You have to molar mass determination of calcium phosphate and calcium 40 with we have three atoms here, so multiply with 3. Then phosphorus with 2, 30 into 2, and oxygen we have 4 to 8, 8, and 16 into 8. So total mass is here. Calculate the mass of phosphorus in 1 mole of calcium phosphate, and the mass of phosphorus is 61. And then we have calculated the percentage. What we have to do, mass divided by molar mass into 100. So we just put the value and you get the answer. It's 19.96 is the answer. And because we need just two significant figures, so it's just round about it, it's converted to 20%. Okay. Next is the question number 5. Ammonium chloride decomposes when heated, and to make hydrogen chloride and ammonia. So what we have to here, the reaction is given ammonium chloride forming hydrochloric acid and ammonia, and it get back, it gives you ammonium chloride. Equilibrium mixture is formed. It's a reversible reaction. State what is the meant by the term in equilibrium. What the term equilibrium stands for include ideas about rate of reaction and concentration of the reactant and product. So reversible reaction, first of all, it's a reversible reaction means rate of forward reaction is equal to rate of backward reaction, and at equilibrium stage the concentration of reactant and product will remain same. So these two are the basic ideas here. Predict what happens to the position of equilibrium when the temperature is increased. As we can see that pressure remains constant. It is you can see the reaction is reversible. Okay, the statement is very clear that ammonium chloride decomposes heat when heated. So it's an endothermic reaction. So it's an endothermic reaction, and if you increase the temperature, the extra energy will be absorbed by the system and it will move in the forward direction. So the answer here is moves to the right side because reaction is endothermic, and to maintain the temperature equilibrium, the extra energy or the extra heat will be absorbed by the system. So it moves to forward reaction. Predict what happens to the position of equilibrium when the pressure increase. We will increase the pressure because we have more atoms on the product side, so it get closer to each other. They react. So position of equilibrium moves to here, let me see. Yes, we have two molecules here, and the reaction will be shift to the backward side, so move to the left. Okay, then we have the next question. Pretty what happens to the rate of backward reaction when the temperature is increased, the pressure remains constant. When the temperature is increased, rate reaction rate will be increased because the particles move faster, they more collide with each other, they have more collisions. Then predict what happens to the rate of reaction when the pressure is increased and the temperature remains constant. In that case, rate increases because their particles per unit volume increases. Greater collision and frequency of the reaction will be greater. So rate of reaction will be backward when the pressure is increases. There we go with the five questions.